Okay, good morning guys. So, balik lagi kita. Problems. Lakta-lakta-latak mga problems. Because para dakot makover since I've been making face-to-face discussion. So, ini is just a video support in case ng mga courses nga kulang in time man pag-meet or mga dinanunulod. At least, di talaga ako makasari nga kulang lang pa ako example because I'm really trying to reach out. Pero kung sakasakali man, dire ko man sala akong reklase. Diba? But I really have to finish my syllabus. So, ada talaga yun pag uh, make up. So, this is my part of making up. So, I hope you have part of your part in making up. So, problem 15, this is about impulse and momentum liwat. To arm up for a match, a tennis player hits the 57-gram ball vertically with a racket. If the ball is stationary just before it is hit and goes 5.50 meters high, what impulse did she impart to it? So, balik ang naging definition of your impulse. Your impulse is, it looks like this. Actually, impulse na momentum, inilat ato ni-discuss or inilat ato i-include yung mga problems. To save time, of course. Momentum of a particle and then impulse and momentum. So, for your impulse and momentum related to here, you can have your impulse J. Your impulse J is just a summation of force and then your time 2 minus T1. So, impulse, may time here. So, imagine na an EU work that is summation of force multiplied by your summation of force multiplied by your displacement. While your for impulse multiplied by your time. So, dito displacement is S. So, digin T2 minus T1. So, amo lagapit ya, di man ya delta T. Ha? Kita later mga notation, they means the same, pero they is time. At to ya is displacement. And your displacement is a vector quantity while your time is not. We usually measure time progressive la, wariya negative na side. Diba? So, that's the difference and the similarities. So, but anyway, if you have a force that is varying, I do believe the second equation is for varying force. Meaning an force na vary. So, diri kalot magkakamiadahin constant acceleration. Which is gin, try talawat hiya pagtanggal dito atong dynamics nga discussion para ma-avoidan medyo magkore-kore or the mathematical side. Pero as much as possible, kini-include tahiya. Diba? Kaya mahilaba man duro kung nag-include tayo nga tanan. So, mga patapsing la animo calculus part. So, this is a mathematical side. So, kung makita nga ni kong problem nga varying force, so, treat ito sa mathematical because ako, agi susugad ko lahiya. So, kung mathematical, takpag treat, bagalay ang calculus. Pero kung situational, you really have to analyze. Diba? So, I do believe physics is more on diri ko diha mathematical nga description kada na medyo alien niya. So, adi physical niya or situational nga description para gina-analyze ta gud ginihimay ta niya mga kung ano ta ada. You can also define your impulse as the change in momentum. Your momentum is P. So, from the definition, your momentum is mass and velocity. Mass times velocity. So, may dihap niya mathematical description, no? That is the derivative of your summation of forces is the derivative of your P. O, sorry, yung summation forces actually, kung may mo graph of P versus time, so, momentum, anim, kaya pwede ka man mag-graph in momentum. So, pira na to ka graph, may the VXT, may AXT, may F, ngan time nga graph, and then here, may the mo momentum nga graph. So, kita, iba-iba tira nga mga graph. But if you have a graph of that, the summations of forces is actually the derivative of that or the slope of that. So, kung diri mo straight line, so that would give you a function for summations of forces, meaning varying it mo force. So, i-connect Lara. Okay? So, for this problem, actually, what makes this two-dot problem, because I've been looking at this, or pag mag-solve, so, dire-diretso yun, when mag-save ako, i-delete ko man lahat video. Problema kasi ni kay nakita na kamo mga problem nga may kita tutulong nga motion aw duduha nga case nga motion ini. Ngan ini nga stationary before ini lumagpot ang bola. Ngan ini nga 5.50 after na lumagpot ang bola. So you have to separate these two because stationary meaning an ito ball mababalbag pala stationary tas kabalbaga iya before hiya lumagpot meaning an imo bat nga nanimo ball in contact amo ini nga part ini dinhi. Pero ini waray na niya din nga part because your 5.50 meters would be under your kinematics na nga rule. So, sir, so paano man sir? So, I do believe ibulaga it imo motion. Kita ni. Ini nga dukot pat imo racket. Actually, may dat niya di the time. In fact, may mga problem kita nga sugad dito iya discussion an imo ball madukot pa nga dihan imo ngan imo racket. Ngan iton an imo constant nga force dida or force nga in contact amo tiyan nimo sa mission sa force. Pero paglagpot na niyo ani mo sa mission sa forces dida kanan gravity na la alone which is kinematics na yang side. So ganito pag-analyze. So kung i-plug natin the equation, of course iba in motion na di, ibang equation na di, ibang equation na di. Para niya duha nga ginhatag, meaning if you're going to use the stationary, so meaning ani mo velocity adto dito VO, if you going to use the stationary, you have two velocities for that. So your stationary velocity which is VO and your final velocity and pagbulag nira in contact. 'Di ba? And these two will be governed of course by you can have a um you can have a dynamics nga kinematics nga description nito, then you have Vx squared or Vy squared is equal to Vo tayo na kayo na pixelize. So your Vo squared minus your acceleration. Vo squared, that is your 2 acceleration distance or y2 minus y1. y2 minus y1. The problem with this one, pwede mo iniig 0 and then you can compute for this Vy. Ini nga imo y didit paglagpot. Okay? Kaya lang, ini nga distance, dito siya ang ginhatag nga 5.50. Because again, this 5.50 is after ito nabuhian didan, which is so small, ito yung distance in contact. In fact, the time gap ito, gita enduro. Ngayon nga 5.50, assuming itong after na hiya mahit, nga nagdalaga niya ito 5.50. So, basically, if you want to compute this, waray kayo nga y2 minus y1, kaya waray matighatag dito ng description. Okay? But instead, what you can do, you will go back to this equation and then you zero the Vy. You zero the Vy squared. Kaya kay at that 5.50, marireach niya ang pinaka-height. Ang saring kasi nga ma-reach yan height. So, meaning, it's the maximum. Vertically, if the ball is stationary just before it is hit and goes 5.50 meter high. So, meaning, aniya pinakataas ito. Makadtuya 5.50. So meaning, iti mo Vy dito is 0 and then you can compute for this Vo. Okay? But this Vo is actually the final velocity han imo kanina nga kundi ma-impart kahin impulse. Kaya actually, impartation nimo impulse, an imo pag connect kanimo bat ti pakadian ball before it leaves the bat. That is the impartation of that impulse. Wala nga mo tating calculate. But of course, pag stationary na niya, pwede tayo siring, ano nga impulse na niya hatag ito nga ball para umabot yan 5.50 meters. So that's what makes the problem complicated. Okay? So but anyway, so we have already figured that out. Meaning, ini nga imo VODD nga equation, pwede na kita gumamit didihin Vy squared nga masisiro, Vo squared minus 2, ang ato na A din is G na hiya. Because didi nga side, may acceleration from 0 to a particular malaksiya, that's an acceleration, pero tikang din yan, lumagpot na ya, kutob 5.50, it governing na lang ito dida nga acceleration is your G, the pull of gravity. So meaning, 2G, and then you have your 5.50 meters. So basically, this is VO squared. So you can compute actually for that VO squared. Okay? Which is 2G and then multiplied by 5.50 meters. So that is your initial velocity after it leaves the bat. So may talaga niya velocity. Pero ato nga sinisiring at rest is before yan mo na hithan bat, kutob nga naglagpot hiya. Okay? So anyway, so you already have that VO. Yes, I can compute that. That VO would be the square root of 2G 5.50 meters. So, anyway, solve ko na siya. And then, going back to the problem, maron ako solve ko na siya. What impulse? So, if you will talk about that impulse J is actually equal to P2 minus P1. So, ini nga impulse, again, tikang inididingan didi. Han kumbaga, ani mo bat, ani din nga part, di ba? Di ba? Ada nga part in contact. So, this is your P1, this is your P2. Okay? And then your P1 would be an imo na ito at rest. So, din ka na makakagamit ang imo P2 minus P1. Dere ang time nga ini makadiyaditi. Okay ha? Kita niyo itong analysis din ang aside. I hope you can appreciate how you will analyze problem. So, meaning, ini nga P1 is 0 because magagamit mo na ang word nga initially, it is at rest. So, meaning, your impulse actually is just equal to P2. Meaning, ang P2, that is just equal to mv given that your v is this velocity here. Okay? And of course, you will plug your mass. The mass of the ball was given. That is 57 grams. So, imunta yung kilogram, that would be a 57 times 10 to the negative 3 kilogram. So, ang negative 3, amit on kilo. Gimbutang ko in between na 57 grams. So, ini nga kilo is 10 to the positive 3 tapos 10 to the negative 3 ang makompensita iya. So, para diretso. So, 57 grams. So, I read this as 57 grams. And then your velocity to be the square root of 2 times 9.80665 meters per second squared. And then you will have your distance 5.50 meters. Okay. And that you would have 57 exponent negative 3 times the square root of 2 times 9.80665 times 5.50. Okay? And then, chireng. So, it magawas hindi is a meters per second. So, your unit of your impulse is mass times velocity. So, that is mass kilogram meters per second. Okay? So, that will give us 0.59 0.59 into significant figures. Kita ang tanan problem. Ano niya mga ginatag? So, that is 3 significant figures. So, 0.592 unit would be kilograms meters per second. So, that is for anyway, letter A. Okay? So, thank you guys for listening.